Hello everyone, welcome to the class. This is Mohan Raj, your trainer, and this is Genesis Training. We are seeing continuous videos in Speed Maths, and this is going to be the last video in Speed Maths series. Okay, so we are going to now see how we can use algebraic identities in solving the questions. Application of algebraic identities. Let's see. First, before getting into the questions, we need to recall the identities which we have learned in our school days. So these are the identities you can look at: a plus b whole square, which is a square plus b square plus 2ab, which is also written as a plus b into a plus b. And same with the minus sign for a minus b whole square. And the square of a plus b plus c whole square is given here. You can just observe that. A plus b whole cube, also you are aware of it. And a plus b plus c whole cube, which you might not be remembering. So a cube plus b cube plus c cube plus 3 into a plus b into b plus c into c plus a. I can also write a plus b whole square as a plus b whole square as a minus b whole square plus 4ab, and a minus b whole square as a plus b whole square minus 4ab, which will simplify to this only. Okay, so a cube plus b cube is a plus b into a square plus b square minus ab, and a cube minus b cube is a minus b into a square plus b square plus ab. And this is one important identity. We are going to use it in some questions. A cube plus b cube plus c cube minus 3abc, which is already proved to be equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. What happens if this equal to 0? If this equals to 0, I can equate this entire part as 0. So I can write a cube plus b cube plus c cube is equal to 3abc. So we have one question regarding this. We will understand this better in that question. Let's get into the examples now. Before that, we have to also understand this rule. The identities in the previous slides are widely used. We know that. So below are the important finding in a square and cube, etc., which helps us in finding the remainder when we divide by a particular number. For example, they are given a power n plus b power n is divisible by a plus b when n is odd. That is a cube plus b cube, we know, which is written as a plus b. As an example, I am telling you, into a square plus b square minus ab. Because it is odd, I can say it is divisible by a plus b. In the place of 3, if there are any other odd number also, we can definitely say this number is divisible by that number, a plus b. And a power n plus b power n is never divisible by a minus b. We will never get a minus b in this place. And also a power n minus b power n is always divisible by a minus b. For example, we have a square minus b square is equal to a minus b into a plus b. Whereas we also have a cube minus b cube. Whether it is odd or even, we will have a minus b term in that, and remaining that is not required for us right now, which is a square plus ab plus b square. Right? So a power n minus b power n is divisible by a plus b only when n is even. So in this example, n is even, so it is divisible by a plus b. So these rules will be helping us in understanding and solving few of the questions when they ask about divisibility. Okay, let's come to the question here. First question. This is nothing but 105 into 105, which is 105 whole square, and 92 square. And we know how to expand this. It is 105 plus 92 into 105 minus 92. So 105 plus 92 is actually 197 into this is 13. And we know table of 13s to calculate this. 13 hundreds are 1300, 13 90s are 1170, and 13 sevens are 91. So when we add this, we get 2561. That's your answer. And another question related to the same identity: 64 square minus 36 square is equal to 20k. Find the value of k. So before solving this in a minus b, a plus b format, let me take something common among them, which is 4 square is common in both of them. Make it simple. 4 into 16 square, 4 into 9 square it is. Now it's even more easier, which is equal to 20 into k. 1 4 will cancel with this. I can make it as 5 now. So 4 into, now I can write 16 plus 9 and 16 minus 9, which is equal to 5k, which comes out to be 4 into 25 into 7, which is equal to 5k. Further, I can cancel 5 ones are 5 fives are. We end up with 20 into 7. K is equal to 20 into 7, which is nothing but 140. That's the simplest way to solve this question. Okay. So let us look at the next example. If a plus 1 by a is equal to 5, find a square plus 1 by a square. For this, I am going to make use of a plus b whole square identity, which will give you a square plus b square plus 2ab. In the place of a, we can write a only. In the place of b, we can write 1 by a. So what happens is a plus 1 by a whole square is equal to a square plus 1 by a square. This is the part we have to find out. Plus 2 into a into 1 by a. So this will anyway cancel out. And we know what is a plus 1 by a whole square, which is 5 square, which is equal to this something we have to find out. This is the value we have to find out, plus 2. So when you solve this, we get to know a square plus 1 by a square is equal to 25 minus 2, which is 23. That's your answer. Let's look at this example. Root a plus root b is equal to 17. I take it as one equation. And root a minus root b is equal to 1. It's second equation. I need to find root a into root b. That is root of a into b. Right? This is a very simple question. It looks like a difficult one. We just have to make use of simple linear equations. When we add these two equations, what we get is 2 root a is equal to 18. So it will tell us root a is equal to 9. So when I substitute in any of the equation, we get root b is equal to root a minus 1, which is, I can say this, I can use this equation, root b is equal to root a minus 1, which is 9 minus 1, which is 8. Now my question is root a into root b, which is actually 9 into 8. Simply the answer is 72. Fine, this is a very easy question actually speaking. Let's look at the last one. A cube plus b cube plus c cube. We know the expansion of this, right? Which is actually, you can just look at this expansion if you want. This is the expansion talking about a cube plus b cube plus 3 cube minus 3abc, which is a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca, right? So that's what we are talking about. So this is, but we don't have to look at the entire expression anyway. This is a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. But I told you when this is equal to 0, I can say a cube plus b cube plus c cube will be equal to 3abc. Now let's check what is a plus b plus c. A plus b plus c, they are given 87 minus 127, which is minus, so 87 minus 127 plus 39, which is actually giving us, this has to be 40. Let's change the question to 40, then only it will be easy for us. This is minus 40 plus 40, which is 0. So in that case, I can say the answer as a cube plus b cube plus c cube should be equal to 3abc. 3 into 87 into 127 into 40. So it is simply a product of this, which you can anyway solve this and get the answer. So the idea is to get to know how to get the solutions for this. Okay. So that's the end of this class. That's how we use the algebraic identities, but you have to practice more and more questions to get use of this. Okay. So let's connect back in any other topic later. Thank you so much.